Hello everyone, this is Venugopal. I am your mentor for geography. As part of this session, we will discuss about the basic concepts of physical geography. Now, what is physical geography? Physical geography is about processes and patterns that occur in our natural environment. When I say processes and patterns, how do we understand them? And why do we need these processes and patterns? And why should we understand this in our natural environment? Now, we all know that we talk about monsoons. So, monsoons have a set pattern. The set pattern, when I say set pattern, we have southwest monsoons. That means the winds flow in one direction. And eventually, we have the winds flowing in the opposite direction. This was used in the past to trade across seas. So, that means when we studied the wind pattern, that they flow in one direction in one season and in another direction in the other season, that helped us to do business, that helped us to do sea trade. Similarly, when I say processes, now if you see any Himalayan river, we read in newspapers that they are carrying a lot of debris along with them. But again, when they flow through the Himalayan rivers, flows through the Gangetic plains and then ultimately deposit whatever sand or loamy soil that they have, they deposit that in near the coastal regions. Now, if this is a process, that means a river would erode the material. When I say erosion, it exfoliates or it removes the top material from a mountain or a high-lying region, flows through the plains where it continues to deposit the material, and the finer material is deposited in the coastal region. That means this is a process. And earlier I talked about a pattern. So if we understand these processes, if we understand these patterns that are happening in our natural environment, it would be easy for us to understand our existing environment. In case tomorrow we are trying to plan to develop a new city. If you are planning to develop a new city, we need to understand the physical environment in that particular area. Now, a classic example, let's take a classic example. Mexico City, which is the capital of Mexico, is in a seismically active zone. I would say it is precisely wrongly located. Why? Because it faces it is in a very seismically active zone and there are continuous earthquakes. So, would I have to plan a larger city in that area where it is prone to earthquakes? Ideally, no, because the amount of money I'll have to spend to make a particular structure earthquake proof makes the cost of the building exorbitant. So that would also inhibit growth of larger cities. So these kind of activities, this kind of knowledge is very much essential for us. So to understand our physical environment, we need these processes, we need these patterns. Now when I say processes, when I say patterns, we need to understand our land, which is called as lithosphere. We need to understand the atmosphere also, because if we understand the precipitation in a particular area, if we understand how the water moves in that particular area, the drainage patterns, etc., it will help us to understand if we can provide enough water to that particular city. Again, I am taking the example of building a new city. So if it is too hot, or if it is if it is in an area where there is lot of precipitation and there can be submergence, would I go and build a city over there? No. So that's why we need to understand our atmosphere also. That is why if you see, right, if you take the example of India, why do Bangalore and Hyderabad prosper? Because favorable climatic conditions. So if you understand the atmosphere, you would be able to invest in a particular area. You will be able to, as a country, we can take certain decisions that will help us prosper. See, if you read in newspapers, every time we see that Mumbai, there is a heavy precipitation predicted, please do not come out of your houses. So would I go and start a business in that particular area? No, right? Yes, because Bombay being in a colonial city, it is continuing to prosper. But when I am planning a new city, should I take that extra energy? Should I spend that extra money to start a new city over there? No, right? Then we talked about atmosphere. We also will talk about hydrosphere. That is, what is the availability of water in that particular area, right? How the water cycle moves in that particular area. Then the last one is about biosphere. What is biosphere? Again, biosphere is nothing but zone of life. Why I say it is a zone of life? Because when a particular living organism interacts with soil, it interacts with atmosphere, it interacts with hydrosphere. So biosphere interacts with every other sphere. It is nothing but it is sum of all ecosystems. Now, if you see this particular diagram, I am saying biosphere interacts with lithosphere, hydrosphere, atmosphere. That means it is in a layer of intersection of all of these three circles. So it is very much important to have an understanding of biosphere. Now, in UPSC papers, if you would see in previous preliminary examinations, there is an unusual weightage for biogeography. Now, should I study biogeography in silos? Will I be able to answer the questions just like that by just studying biogeography? No. Why? Because you need to have an understanding of lithosphere, you need to have an understanding of atmosphere, you need to have an understanding of hydrosphere as well. So, if we focus on understanding these concepts in a better fashion, we would be able to answer the questions that are asked on biogeography. That is why we say biosphere is a sum of all ecosystems. Okay? Now, we are talking about lithosphere. What is lithosphere? As part of this session, right, we will go in detail on what is lithosphere. Lithosphere is the outermost crust, outermost shell of the earth. When I say outermost shell of the earth, what is the radius of earth? The radius of earth is 6400 kilometers approximately. Now, how wide is lithosphere? Lithosphere is just on an average 35 kilometers of depth. That means if you take the volume, it is approximately 1 to 2% of the volume of the entire earth, right? So when we say lithosphere, lithosphere is about the outermost shell of the earth. It is of average 30 to 35 kilometers of depth, right? Again, I just mentioned about the volume also, right? Approximately 1% of Earth's total volume. And I said the depth is average of 35 kilometers. Now, why I am saying average? That is where we need to discuss. When I say lithosphere, does it just include our continental crust or does it include the oceanic crust also? Because when I am saying the outermost shell of the earth, now when did water come into existence? When did oceans form? In the Hadean eon. When I say Hadean, again we will discuss about the geological time scale later on, but that means Hadean is the first 500 million years of formation of the earth. Earth is around 4.6 billion years old. In the first 500 million years old, in the first 500 million years, what was happening? The earth was a molten material which were coming together and there was sorting of different layers. That is, the denser material was going deeper, the lighter material was coming upwards, right? There was sorting, there is stratification, different layers were forming around. That was happening in the first 500 million years. That means that is when we had this outermost shell forming. When the outermost shell was forming, we don't have any water, we didn't have any oceans. So that means when we talk about the lithosphere and when I am saying we talk about the outermost shell, it should include both the continental crust as well as the oceanic crust. That means the ocean basins also devoid of water. So it includes both continental crust and oceanic crust. Now we all know the oceans are pretty deep compared to our land mass. So that means what? The continental crusts are of higher depth compared to the oceanic crust. That is clear. That is why we talk about the concept of average depth of lithosphere. Now again, when I say average depth, is it just this reason that we are saying when we say continental crust and oceanic crust being less deeper compared to continental crust? No. There is one more reason also. You see this diagram. I just gave this example of continental crust where we have mountains, the land mass, etc. And we have the oceanic crust where we have the oceans and the region here. This is called as the oceanic crust. right? This is the continental crust, right? Now, are you noticing something? We have a mountain here and we see a subsidence of the lithosphere into the next layer, a little bit of subsidence of the lithosphere into this particular region. That means the depth of the continental crust increased where we had mountains. Why? Because let's take an example. If I have a heavier density material, you see here, or a material of larger volume or larger weight, if I am having a larger wood, you see the submergence is larger. If I have a smaller wood, the submergence is smaller, right? Presuming it to be of same density. These two materials are of same density. But since though the density is same, because the volume is more, the weight is more. That means it subsides more into the water, right? Similarly, if I go to the previous example where we had mountain, right, in the continental crust, where we had mountain, let's again we are assuming that the density of the continental crust to be equal. In that case, if you see, I have a mountain. If I go to the previous example here, I have a mountain here. From here to here, I have a mountain. That means the volume is more. That means since this and this have the same density, but since the volume is more, that means the weight is more. That means this particular region has to subside more. See, that's why the mountain is subsiding more into the next layer of which follows lithosphere. That is why when we talk about the depth of lithosphere, we say it is of average depth of 35 kilometers. But what is the maximum depth? The recent studies, when we talk, because Himalayas are the tallest mountains on the earth. So that's why when we talk about Himalayas, recent studies, we found that it is about 55 to 60 kilometers depth. So the continental crust has a maximum depth of 55 to 60 kilometers where we have Himalayas. Okay. Now, what about oceanic crust? Oceanic crust is around 5 to 8 kilometers in depth. Again, this also varies because it depends upon the density of the material, depends upon the topography. When I say what are the landforms in an oceanic basin, they also make, right? Because there are mountain ranges even in ocean. So that's how it varies there also. Now, when I say continental crust, oceanic crust, again, let me go back to the previous example. When I was discussing about this molten earth, I just mentioned about heavier material subsiding in, lighter material moving upwards. The similar thing could have happened in the outermost shell also. So when I say this is the, of course this is not fit to the scale, but again let's assume that this is the 1% volume that I am talking about, which is lithosphere. Even in this layers also, which is the continental crust and the oceanic, includes continental crust and oceanic crust, there should be some sorting of material, right? So lighter material should come up, heavier material should come down, right? So in that case, if the sorting happened, if I have here, right, if I am illustrating this in this diagram, the upper content should be of lighter material, the lower material should be of denser material, right? So that's why majority of the continental crust is made up of, they say, consists of granitic rocks. So you will find more of granitic rocks in the continental crust, right? Again, lower part consists of basaltic rocks. Basaltic rocks. So in a continental crust, let's say if this is continental crust, the top part will be of granitic rocks. The lower part will be of basaltic rocks. Now, that means what? The inference here should be basalt is of more density compared to granite. Now, when we discuss about igneous rocks, when we discuss about volcanism, we will try to understand how this density plays a role in understanding different rock forms, different features of land. Okay. Now, this diagram illustrates what I have explained earlier. Presuming this to be a mountain chain, which is Himalayas, that means, see, there is a larger dip here, right? That means the depth of the lithosphere increased in this case. Again, this is a very good example. This is a phenomena that has been observed in the recent past. When I say recent past, do not take into consideration like last 1 year or last decade. In geographical time scales, recent past could be 50, 100 years also. Now, I just explained a scenario wherein if there is a mountain, since mountain will cause more weight to have on the lithosphere in this layer, that is why there is a larger depth. That means this is shrinking into the next layer, which is mantle. After the lithosphere, we have that which is crust, we have mantle. It is shifting deeper, right? Now, let's say we all know that there will be wind erosion, there will be erosion by rivers, etc. That means this mountain is being eroded. That means there is a material that is being removed from here and getting deposited somewhere else. Let's say eventually this mountain is completely eroded. So what they say is, if it is completely eroded, the weight is reduced, there is a rebound, which is called as crustal rebound. So this is what you need to understand, right? Similarly, here we talked about mountains. Now there is another phenomena. In places like Canada, in Scandinavian countries, with greenhouse effect, when the ice is melting, right, when the ice caps are melting or the glaciers are melting, the thick sheets of ice started melting. Then what happened? Imagine instead of a mountain, thick sheets of ice. So when these thick sheets of ice were present, the weight was more, the land mass was little bit subsidence. There was a little bit of subsidence. But when they all melted, what happened? So what they are observing is the glacial melt is causing the land to rebound. That means the land is slightly moving up. So this is how we need to understand these concepts. This is a process. This is a pattern. We need to understand these kind of things, and this helps us in understanding how to plan in the future. Now, there is another classification. So on the lithosphere, we have different landforms. When I say landform, mountain is a landform, mountain chain is a landform, hill, a small hill that is of lower altitude, that is also a landform. We have river valleys, those are also landforms. We have plains, we have deltas, those are also landforms. But again, if I have to study them, how should I classify them? There is a classification. At a broader level, there is a classification of all these landforms that are found on the lithosphere. So they are called as crustal order. That means what are being found on the crust, we classify them into 3 different orders or 3 different categories. The first order, second order and third order. That means there are 3. Now what is first order relief? Relief is nothing but the shape of the landform, right? So first order relief means what? The coarsest level of landform. That is when the earth actually formed. I was talking about the Hadean, right? Which is the first eon, when the first 500 million years, when the first time when the earth formed, we had a continental crust and oceanic crust, right? That is called as the first order relief. Now, when some forces act on this first order relief, like it could be erosion, it could be any seismic activity, it could be any other forces that are acting inside the earth or outside the earth, right? That can cause a change in these landforms. So when some external forces act on this first order relief, when I say external, let's not think about just the forces outside there, it could be internal also. Something else is acting on this first order relief that would cause the shape to be changed, or that could cause a new kind of landform to be formed. That would lead to the second order and third order relief. Okay? That could lead to second order and third order relief. So what is second order relief? So we just first said that the coarsest level, which is nothing but the outermost layers, the continental crust, oceanic crust, we are calling it as first order. The second order should be inheriting its structure from the first order. This is called as intermediate level. Why? Because this is between the first and third. Obviously, that means some forces are actually acting on this second order relief, which would cause the third order relief also. That is why this is being called as an intermediate, because this is transition between the first and the third. Okay. Now, what are included in this? We have plains, we have continental shelf, right? We have oceanic trenches. Now, we'll go in detail on what these are, how these are, why these are called as second order reliefs. Okay, we'll discuss in detail, but for first we need to understand what they are. Then we'll discuss about how they are coming into existence. Right? Continental slope, when you are going to discuss about the oceanic basin, we'll discuss about what is an continental slope, abyssal plains, oceanic trenches, etc. Okay, but for now, just have a fair understanding that there is an intermediate level between the coarsest level of landform and the final landform. What is the final landform? Which is nothing but valleys, gorges, canyons, cliffs, mountains, etc. Right? Cliffs, these are called as third order relief. So these are most detailed. That means when forces are acting on both first order and second order, we will have this third order relief. Okay? Okay, let's discuss this question. Okay? Consider the following statements. Lithosphere includes both oceanic crust and continental crust. This is the first statement. What is the second statement here? Oceanic crust is much thinner than continental crust. Now, the first statement is true because we were discussing earlier. It includes both continental crust and oceanic crust. And also when we discussed about the depth of lithosphere, we said that the depth of the oceanic crust is 5 to 8 kilometers in depth, whereas the continental crust is about 35 kilometers or more than that. Where we have mountain chains, it could be up to 55 to 60 kilometers. So both the statements are correct. But let me twist this particular statement a little bit. Instead of thinner, let me say denser. Now in that case, what happens? In that case also both the statements will be true, because earlier I was giving an example of granitic and basaltic. We were discussing about granitic and basaltic. We said continental crust or the lithosphere, the topmost regions of lithosphere would be of granitic nature. The bottom regions would be of basaltic region. Right? So, oceanic crust is more of basaltic in nature. Hence, since basaltic is more denser than granitic, this statement would also become true. Clear? Let's move on to the next question. Consider the following statements. Continental crust is made up of lighter material. Oceanic crust is made up of denser material. We just discussed earlier where I changed the statement from thinner to denser. These are exactly the same. Right? Again, both the statements are true. Now, how can a mains question be? Right? Describe the evolution of layered structure of Earth along with the formation of lithosphere, atmosphere and hydrosphere. I understand that we haven't discussed atmosphere and hydrosphere, but this could be part of the question is about lithosphere. In this case, we need to explain how lithosphere came into existence, different layers in the lithosphere, the depth, the varying density. We need to talk about granitic, basaltic. We need to talk about continental crust, oceanic crust. We also need to talk about the average depths. We also need to talk about that there is an increase in depth where there is a mountain chain. Okay. In the next session, we will take up another topic. We will continue. Thank you.